In today's video, we're going to be talking about color. After watching this video, you should be able to understand why objects appear to be different colors, understand what the primary and secondary colors are, and then be able to color mix and color subtract by using primary and secondary colors. So let's get right into this. The first thing is just a refresher, a reminder that light is an electromagnetic wave. And basically what that means is an electromagnetic wave is a wave that is capable of traveling through a vacuum, which is just the opposite of what a mechanical wave is, which is something that is not able to travel through a vacuum. It needs a medium in which it can travel through. Okay? And electromagnetic waves are classified based upon their frequency. So if we take a look at the electromagnetic spectrum, there's a whole bunch of things in it, okay, and you're probably very familiar with. You have things like radio waves, microwaves, infrared light, and then here in the middle where you see this rainbow, this is the visible spectrum of light. And this basically is the part where our eyes can see this little piece here, which is pretty crazy. That's such a small piece of the electromagnetic spectrum that's actually visible to our eyes. And then moving on from that, you have ultraviolet, X-rays, and gamma rays. And basically, starting from the right, moving to the left on this guy, the frequency increases going from right to left, and the energy increases going from right to left. Okay, so radio waves have considerably less energy than, say, gamma rays do. Okay, but we're not really that concerned with those things right now. What we're really focused on is the visible spectrum of light. Okay, so let's go right into that. The visible spectrum includes basically all the colors of the rainbow, and that'd be red, orange, yellow, green, blue, indigo, and violet. And you guys may have heard of this term before, but a lot of times this is abbreviated by this guy named Roy G. Biv. And it's just a way to remember your colors, where each of these letters is one of the colors in the visible spectrum. Okay, and each color has a different frequency. Very small difference, but a difference. Okay, so what we're worried about is like, well, how come different objects appear to be different colors? What makes that happen? So like, why is the grass green? Or why is my shirt today black? Or for this slide, why is that shirt red? Okay, and the color of objects that we see is basically due to the way that the object interacts with the light that is illuminating that object. Okay, so if we go with this example of this red shirt, okay, which I know I'm using a blue pen, which doesn't help, but here's this red shirt. Okay, it is red. How come it appears red? Well, basically what's happening is light, white light, which includes all the colors of the rainbow, Roy G. Biv, strikes this shirt. And this shirt is basically going to absorb all the colors of the rainbow except one color. Can you guess which one it might be? If you said red, you're right. Basically, only red reflects off of the shirt, and here is our eyeball, this kind of freaky looking eyeball, just floating in space, picking up that red frequency. And so our eyes perceive this shirt to be red colored. Okay, it's not that the shirt itself decides I'm going to be red today, okay, and starts to like give off a red color. Okay, remember that the shirt itself is not lighting up. Okay, it's only due to light reflecting off of the shirt itself. Okay, so let's do some examples here. Here we have on the left, example A, white light, which is represented by this arrow here, striking this piece of paper, okay, and white light contains Roy G. Biv, right? The paper is capable of absorbing Roy Biv, okay? One letter is missing. What letter is that? Well, it's G, right? So this paper is going to reflect G, and G stands for green, okay? So it's reflecting green light. So if our eye was here picking up that reflected light, this paper would absolutely appear green colored, okay? Let's do another example. Here we have white light striking this piece of paper. Okay, remember white light contains Roy G. Biv. All right, and it says the paper is capable of absorbing Oy G. Biv. Oy G. Biv. That's kind of fun to say. So the white light hits the paper, it reflects off, and all the colors are absorbed except one, and there's a letter missing, and that letter is R. Okay, and so this paper would reflect R, or red light, and it would appear to our eyes as red colored. Okay? And that's basically what allows us to see different colors. Now, if you're curious about like, well, what about black? Okay, like my shirt, how come it appears black? Basically, my shirt absorbs all the colors of the rainbow, all of Roy G. Biv, and no color reflects off of it. So our eyes take that as black. Okay, so black basically absorbs all the colors of the rainbow. Those of you who are art students or really into art, well, this will probably be very easy for you. If you're not, it might be a little bit trickier. It's just a matter of kind of memorizing some stuff. But there's these things called primary colors, okay? And there are three primary colors: red, green, and blue. Okay, so only three to remember: red, green, and blue. All right. If you mix red, green, and blue together, you actually also can produce white light. Okay, so red plus green plus blue will produce white. Okay, so there are other ways to produce white light than just Roy G. Biv. If you do red, green, and blue, you get white also. So here's an example of doing some color mixing. If you take just two of the primary colors, red and green, and you mix them together, you're going to get yellow. Okay, or if you take red and blue, you would get something called, I believe this is magenta. And if you get blue and green, and you mix those two together, you get something called cyan. Okay, that kind of, I call it teal, but cyan, I guess, is what you'd call it. And this is red, green, and blue, and then here are your colors that we just mentioned in these three pictures here. But if you look at the very center, if you mix all three colors, what do you get? Well, you see white light there. Okay, so again, you can mix the primary colors to get different colors also. Mixing of the primary colors, or at least two of the primary colors, will get you something called secondary colors. And the secondary colors are yellow, magenta, and cyan. Okay? And basically, these guys are produced by mixing two primary colors of equal intensity. Okay? And so this might be something you might want to have handy dandy in your notes, this kind of color mixing formula, if you will. So if you mix red and green together, you get yellow. If you mix red and blue together, you get magenta. And if you get green, or if you mix green and blue together, you get cyan. Okay, and that's how you can produce the secondary colors. One of the things that another way you can get white light, I should say, is by mixing a primary color. Okay, so a primary color can be red, green, or blue. Okay, if you mix a primary color plus a secondary color, you will actually also produce white light. Okay, and it has to be a specific combination. Okay, and I'll explain why in just a second. Let's say you have red light. Okay, if you take some red light has this complementary color called cyan. Okay, and cyan, if you recall from the previous slide, to make cyan you need green and blue. Okay, so what that actually, if you mix red light and cyan together, you actually do get white light. And you may say, well, how come? Well, remember at the very beginning here, I said if you mix the three primary colors, red plus green plus blue, that gets you white light. Okay, so keep that in mind. If you take red light and you add it to cyan, that also produces white. And again, you might be saying, well, how come? Cyan, if you break that down, is actually green and blue. So red plus green plus blue produces white, just as I mentioned over here. Okay, so complementary colors, a complementary color to a primary color can produce white light, but it has to, basically, if you break it down, it has to come down to that you have the three primary colors to produce that white light. So there's something called color subtraction, and color subtraction is basically when you illuminate an object with a certain color of light. Like, it's not always going to be white light. Okay, so sometimes I'll, like for a Halloween party, I'll change the bulbs in my lamps to be, orange or something kind of like scary or whatever. That would be a different color light that's illuminating all the objects in the room. So you have to take that into account along with what colors the object itself absorbs. Okay, and so this can get a little tricky when you start talking about color subtraction. But in the end, you just have to kind of think about what color light is hitting the object, what does the object absorb, and then based upon those two factors, you can figure out what color of light is reflected, and whatever that color is, that is what color the object appears. Okay, so an example I think will be helpful here. Okay, so let's say you have white light, okay, shining on a shirt. So it's red, green, and blue, okay, or Roy G. Biv, whichever you prefer. Here's my shirt, okay. This white light hits this shirt, okay, and it says the shirt absorbs blue light. It absorbs blue light. Only red and green is reflected from the shirt. So coming off this shirt, you have red plus green. And here's that freaky looking eyeball again. All right, looking at this, it's seeing the red and green light hitting your eyeball, and your brain is perceiving this as a color. What color does it perceive it as? Well, if you go back to your notes and you look at secondary colors, what secondary color is red plus green? And if you are thinking about that, you should be saying, well, yellow is red plus green. And so what color will this shirt actually appear? It will actually appear yellow, okay? And basically those two colors mixing together will produce a yellow colored shirt. We'll do some practice problems with this in class, so don't worry if you're confused. I know I'm throwing a lot of colors at you all at once, but once you start to do it, it's not so bad. That takes care of this video. I will see you guys next time.